Hello everyone, my name is Ashok Samal. I'm a part of Microsoft Western Europe, specialized in big data and artificial intelligence. And today I'm going to talk about 6 practical points from my personal diary to consider while you deploy AI in production. Stay tuned to it. We all know AI has a huge potential in every respective field, but while doing it, are you sure that you are taking the right step to implement it? And the first point I would like to talk about in the AI is explainable AI. A lot of people just implement black box. They even don't know what is inside that black box, and that goes to production. Super scary. And that's my first topic for today. The second one is data drift. So I have seen a lot of developers just get the data, do the magic by using a machine learning algorithm, and then they see, well, my model is 90% accurate, 100% accurate. They're happy about it, and they put it in production. That's too scary. And the third one is model data drifting. So how exactly your model is behaving to live data, and should you be worried about that? That is something on my third point. And the fourth one is AI pipeline. This is one of the best practice how you should implement AI just to make sure you have best in class architecture in place. And the fifth one is inferencing. I have seen a lot of people again doing mistake in this step, and we will discuss how exactly your inferencing should look like in a real AI deployment and production. And the sixth point is operational dashboard. Trust. I would like to familiarize yourself once again on the standard AI architecture that we generally follow at Microsoft in most of the cases. That you have some data sets, the data is stored in somewhere, maybe your Azure storage or some other storage, and then you get the data to train and test and evaluate by using a model, and you run that model or the algorithm inside a training cluster. So once you are done, once you are done with the training, you create or you are satisfied with your algorithm or the training, then you create a model out of it, and then you create a Docker image, and then your inferencing part comes in. Then you create an inferencing cluster and run your model on top of your inferencing cluster to get a web service out. And that is the development side, and that cycle goes on forever. You're going to get new data sets, you're going to come up with new models, you're going to retrain your models, you're going to schedule your job, let's say. But at the consumer side, the consumer, all he needs is a URL and a key, or a REST endpoint and a key. So by using the REST endpoint and the key, if you have the internet connections, you can just ping to the REST endpoint by providing the key and provide the input data, and you will get the output data, which is the output of the machine learning of the AI model. If let me jump to my first point, explainable AI. So recently you would have hearing a lot about explainable AI and responsible AI. The first thing, in order to have explainable AI or responsible AI, you should have 3 things in mind and in practice. Number one, understand. Say no to black box. You have to understand how you have built or your developer have built the model. And we have some open source tools for that. Interpret ML, designed by Microsoft. It's totally open source, you can see how the Interpret ML works at the back. At the same time, the data sets that you use to train your model, it could have a lot of biases. It could introduce a lot of biases that will cause some serious consequences on the end. So you have to be very careful. You should use some open source tools or open source framework like Fairlearn and stuff like that to make sure you understand what is exactly going inside your model and what is really happening inside the model, so that there is no black box at the end of your development. The second one is control. Whatever you do, I repeat, whatever you do, so be getting the data into your storage to put some filters on your data sets and do the ETL activity to deploy your model into the production. Everything that you do inside should be recorded, and everything should be having an audit trail, if you right. And the third thing is protect. And this is really important. I have seen a lot of people, a lot of developers get the data on a flat file or from a storage or from a database, and then they straight get to their workspace, start building their machine learning or AI solution. Now, the biggest mistake they do here is they are actually exposed to live data, the customer data, and they might end up leaving trails of those real data in even if that is not intentional. So you have to be very careful doing this. So you should look for some open source tools, something like white noise and stuff like that, just to make sure that nobody can get the data sets that you are using. Nobody can get the personal parameters from those data sets. What it does, tools like or framework like white noise, what to do is they introduces a lot of noise into your data sets so that it will be highly impossible for somebody to guess the personal information from the data sets. So these are the things that you should be very careful and be responsible while you're building your machine learning model. Apart from responsible, you have to also be explainable what your AI is doing and why your AI is doing like this. So the concept of explainable AI must be in a granular level so that you understand and explain to others based upon each feature of your data sets, how does it impact to your model decisioning. And here I have a diagram of a lot of features. I have a lot of features here, and that is I'm predicting a Y value output. The red dots are living and blue dots are not living. So that's a classification model. And then at the below, you can see that which features are contributing the most to taking the decision the predicted class is living, which are and the probability is 0.731. So it is basically saying which are the features that is contributing to my AI decisioning, right? So in this way, you should be able to explain why your model is taking such decision based upon the data sets that you are providing it to, right? So in order to have those explainable AI in place, we have a lot of machine learning interpretability available here. And you can see here the tabular data sets. We have a lot of those tabular explainer, and then text explainer for text data sets, image data sets, the image explainer. And you must be thinking like it is super difficult, right? And let me show you how I implement it in my project. So if you can see the last code sets here, the explainer equal to mimic wrapper, right? And then I provide my workspace and all the other things, and that is Azure ML explain.model mimic wrapper class, and I'm importing mimic wrapper. And okay, let's jump to my point number 2 for today: data drifting. And right, so what do I mean by data drifting? The change in model performance because of the change in input data sets. There is a lot of reason why your data sets could change. Here is some example why your data set could change over the period of time. Let's say you are getting sensor inputs and one of your sensor broke or a couple of your sensor broke and you replaced with new sensor, and the new sensor is reporting you the data sets with the different measurements, like temperature. Instead of centigrade, it is reporting it to Fahrenheit. And now you have different value in your new data sets. For an example, your sensor broke and you don't know that it is broken, and all the time it is sending you a constant value like 0. You had a particular data sets while you were building this model for the first time. Then you reschedule this model to run once in a week, and you left it from that time. Now, over the period of time, the data sets coming is different, meaning within a week, when it runs for the second time, you have new data sets that might be very different from the first data sets that you never noticed. So your job is to find out, is there a change that I should be concerned about? And that is exactly data drift. So you have to monitor your data sets, what is going inside when you train the model, so that you can find out whether your data is drifting or not drifting. If it is not drifting, well, fine and good. What we can do, we can set up a threshold value. The threshold is between 0 to 1. And let's say if the threshold is less than 0.2, we don't care. If it is more than 0.2, then there is significant change in your data sets. You can change this number 0.2 to anything, right? So if it is more than 0.2, if the data drift value is more than 0.2, then you should be careful about it and you should recheck your data sets, and based upon that, find out if you need to rework on your model. So this is one of the graph I have from the data drift, right, from my project. And if you can see, there is a start date and the end date, and you can see the graph is based upon so many dates. And this is exactly how, over the different period of time, it is contributing to my data drift. So the below, you can see I'm selecting the features, and based upon the selection of the feature, I can see how much they are causing difference to my data sets and over the period of time, right? And then you can select the feature and select the matrices and see how they are behaving over the period of time as well. So this you can get inside Microsoft Azure datasets. So first, number one, you have to register your datasets. Once you register your datasets, you're going to tell to the system that this is my base datasets and declare it baseline, right? Number two, every day you will get, or every week you are rescheduling. So once in a week, you're going to check, okay, I have the 7 days datasets. Can you check the new datasets with respect to my baseline datasets and find out my drifting values? So if the drifting value is more than 0.2, you have to stop, rethink, if necessary, rework, and then move forward. And this is how a quick code snippet of how can you set up data drift and monitor it. So if you can see here, I have a lot configuration and my email ID goes there, or my support email ID goes there. Then I have a monitor here. And my monitor equal to data drift detector that create from datasets. So I have a baseline datasets, I have a target datasets, and then I have a drift threshold. And that drift threshold says me if your drift threshold or drift value is more than this number, let's say 0.2, then it will send an email to the support or to me, so that we can have a look on the data sets again and rethink on what should we do. Should we go ahead with the model, or should we stop it? Should we introduce something new instead of having the old model in place? Let's jump to number 3, model data drifting. So we just spoke about data drifting, and now is model data drifting. And what's the difference? It's pretty much the same. The only difference here is in the data drifting, we were checking the drifting on the input data sets that is going to build the model. What is model data drifting? Let's say you have already built the model and the model is live right now. So based upon our architecture, the consumer only needs the URL or the REST endpoint, as well as the key, the secure key, to access that web service. Let's say your model is live in form of web service and people are querying that web service by using the REST API and the key, right? You made a beautiful model which is predicting with more than 90% accuracy. Now, people are hitting that endpoint, and all of a sudden you see that for some data sets, the model performance is not good. How should you understand and how should you record it? So here is, I have a start date, I have an end date, and this is my web service endpoint, the REST API endpoint, right? So based upon this information, I'm actually continuously monitoring my endpoint, my web service endpoint, the scoring endpoint that I have. I'm continuously monitoring it. And if you can see here, based upon the dates, I can see how much is my inferencing data drifting based upon the real data that I've used to build the model, right? And then you can also go a little down. You can see that with respect to each of this feature that you have in your data sets, how much it is contributing over the period of time to drift. And right, so if you can say here, I have a monitor, I have the same data drift detector, but this time not with the best data sets, not with the target data sets, rather based upon my model, the model.name, model.version, and on my services. And then we have a drift threshold here, which says if you have less than the threshold, it should be fine. If you have a value more than threshold, like in the previous example, I told 0.2, let's consider 0.2 here. If the data drift value is less than 0.2, then I don't care. If it is more than 0.2, then I need to think about it. What should we do? And this is something that you can easily set up by declaring this monitor. And again, if a threshold happens, and it can send an alert to your admin or to your support guys so that you can take respective decision. And then you can actually schedule these monitors, both the earlier the data drift and the model data drift. So you can actually schedule this monitor to run with specific time frame. Let's say once in a day, let's say midnight at 12 o'clock. You can schedule this monitor to run, and you can disable the schedule as well if you're not happy with. So this is the third thing, the model data drifting, that you should think of before deploying your AI model in prediction. This must be a part of your solution. And once a drift is detected, then you will get an email like this. The Azure Monitor alert was triggered, and it will give you a name, and then it will give you a severity, as well as it will give you a search query. Right. So that's model data drifting. Let's jump to number 4, AI or machine learning pipeline. And this is super interesting. Many of our customer and partner doing AI, they don't really have a pipeline in place. What they do, the data scientist or the machine learning expert has written a couple of Python code, and with a lot of fantastic thing in it, and they just run that Python script to or they schedule the Python script to run in production. Now, the biggest problem is when you run those kind of files in production, you really don't have a control of each individual section of the code, right? So you totally miss out the modularity of the code, right? And what I propose here is when you write your code, you make sure you have different script for different part of the code, like data preparation is one module, train the model is another, package the model is another, validate the model, deploy the model, monitor the model is another. And one of the biggest reason why you should do like this is to achieve code modularity. If you change your code to this kind of steps and build it with pipeline, then you can actually define for each of the pipeline what kind of compute cluster you need. So you can define for data preparation, you can have an IO intensive workload, you can have an IO intensive machine, but for the training, you might need a cluster of 5 GPUs. You can see here I'm defining a pipeline state, and that is a step sequence, and I'm writing these are the things will run one after another. As I'm defining a sequence, the first it will run the data preparation step, next the training, then the registration, then the create image, and likewise. And if you focus on the left hand side, this is how a step you have. So you've got a step here. Let's say this is a create image step, then you provide the script name because you have a modular code. So you provide a script name, you provide the machine on which you're going to run with, and then if you have a directory in which you have more supporting files, you can also provide the directories. You can also have more parameters. If you go inside azureml.pipeline.step document, you can see the entire documentation for that. So this is how I create a step, and this is how I create a step sequence to build a pipeline and run that pipeline in production. So that is ML and AI pipeline you should definitely consider. The fifth one for today is inferencing. And so let's see how inferencing works. So we all understand there is a storage where you store your initial data sets, and then there is a compute in which you run the model and then do the inferencing part. And around 50 to 60% of the people I speak about, they say, well, the model building, we do it in this machine, and the same machine is used for inferencing. Now, in order to do the model, you might need a very hi-fi computer. You might need a couple of GPUs to run it, and people are actually using the same cluster to do the inferencing. Let's say you are a retail company and you have a recommendation engine running in production. So you train the model on, let's say, 3 GPU cluster, and you were happy with your recommendation, and you were running the inferencing also there, assuming the 3 GPU clusters are enough to power of your inferencing side of the job. Now, let's say it's a Thanksgiving day, and in a normal day, let's say you get X amount of customer, but in a Thanksgiving day, you get 10,000 times X amount of customer hitting your website and getting recommendation. In that case, you need an inferencing cluster which is scalable, not powerful, because you're going to run this model for the whole year or so, right? So in other days, or 90% of the day, you might not get that much load on your inferencing or the REST endpoint that you were doing, or for the AI machine learning model. But for the 10% day, you need to scale up your inferencing cluster. Rather doing this, can we do something like this? So you got the storage that is there, which is holding your data sets. You got a compute cluster, which is going to be used for only the model training. And then you will have an inferencing cluster, which is actually holding your model inferencing. And based upon the requirement, it can scale in and scale out based upon the need. Let's say in my previous example, if it is not a Thanksgiving day, it can run on minimum number of nodes that you have defined. But whenever the load comes in, let's say in a Thanksgiving day, it can just scale up when you need it to scale up. That is my tip for the inferencing side of the process. And now it's time for the last tip of the day, number 6, operational dashboard. Like I said, 90% of my partner and customer just forget about this. And you can have a quick test if you are one of them. So let's answer my question. How many calls you got to your AI endpoint in the last 2 hours? If you can say it. Or the question, how many failed requests you got in the last 24 hours? Or how many failed requests you got in the last 7 days? Right? What is your machine learning endpoint's response time? If you cannot answer this question immediately, then it is likely that you don't have an operational dashboard at place. And so let me show you how I do my operational dashboard. This is a snip of my operational dashboard. So here, if you can see, I have a time bar on the top, 30 minutes, 1 hour, 6 hours, 12 hours, 7 days, 30 days, and stuff like that. Then at the bottom, I have graphs which shows exactly failed request, number of failed requests, server response time, server request, and stuff like that, right? Do you know the first thing? I didn't build this graph. This is automatically generated because I'm capturing all the logs automatically, and that is basically Microsoft Azure is using App Insights to capture all the logs at the back, right? So, and because we are keeping all the logs at the back, it is able to give you this kind of graphs at operation. And there is a lot of graphs. You might need to customize it. You can actually go to App Insights and you can write your own query there and can build your own graph and can export it to a dashboard to show or to have it for your internal team and keep it ready to track your operational side of the AI. So this is my last tip for the day on operational dashboard. A quick recap what we have discussed today about 6 brilliant tips on AI. Number 1, explainable AI. Number 2, data drifts. Number 3, model data drifts. Number 4, importance of having an AI pipeline. Number 5, what are the things you should take care of the inferencing side. Number 6, your operational dashboard. This is my 6 tips from my personal diary. If you want to learn more about this, or if you have more question on this, you can definitely reach out to me. This is my LinkedIn, and you can find me on LinkedIn by scanning this code. You can reach out to me and ask me more questions. I would be glad to answer you or help you achieve your goal. That's all for today. Thank you very much. Have a good day, guys. Have fun.